Hi guys, welcome to Phoebe Explains. Today's brain teaser is that assume you're a mouse and you just sit at the center of this circle. The radius of this circle is 1 meter and you can run anywhere inside this circle. Your aim is to run out of this circle without being caught by cat. Cat can only move around this circle and cat can never enter this circle. However, there is difference in the velocity between this mouse and this cat. The velocity for the mouse is 1 meter per second and the velocity for the cat is 4 meter per second. So what can this mouse do to run out of this circle without being caught by the cat? Please pause the video to think of a solution. Well, I guess a really intuitive step we may have is that we just run in the opposite direction of the cat. However, as the cat runs at 4 meters per second, it takes only pi over 4 seconds for the cat to run from this point to here. As we know, the circumference of the circle is just 2 pi r, so half of the circumference is just pi. And a time taken is just d over v. Here, the distance is pi, and the velocity for cat is 4, so the time taken for the cat to reach from this point to this point is just pi over 4 seconds. However, it takes this mouse 1 second to reach from this point to this point. So what can the mouse do? Well, I was thinking like if the mouse start from pi over 4 here, when the cat is just at this point, then the mouse can reach this point at the same time as cat. And at the same time, if the mouse is at any point of this segment, for example, here, etc., then the mouse can be at this point earlier than the cat, so the mouse can run out of this circle successfully. However, we know that this cat changes direction when mouse moves from this point to this point. How can the mouse do? Well, it reminds me of my sports class in high school. Although I run slower than my classmate, as I run in the inner circle and my classmate run at outer circle, it takes me less time to finish one circle compared with my friend. So I was thinking if similar method can be applied in this question. So there is cat and we know the distance between cat and the center of the circle is 1, as the radius is 1. And we consider for mouse there is also an inner circle. The radius of this inner circle is r. We know as t is equal to d over v. So for finishing one lap, cat takes like t is equal to 2 pi divided by 4 meter per second. This is equal to pi over 2. And at the same time, for the mouse, the time is equal to 2 pi r, the circumference of this circle divided by 1 is equal to 2 pi r. So what is the value of r? So that 2 pi r is smaller than pi over 2. We can solve this inequality quite easily. So r is smaller than pi over 2 divided by 2 pi. R is smaller than pi over 4 pi equal to 1 over 4. So we know that when radius of the circle r is smaller than 1 over 4, mouse run faster than cat. For example, if rats is originally at this position, when rats finish one lap, the cats may be a little bit lagged behind. So when the rat finished the second circle, the cat is even more lagged behind. So the third circle, cat is more lagged behind. So with time, after running many circles, there is a point where the distance between rat and cat is the largest. So we can see they're in the opposite direction of a diameter of a circle, and the cat is at this point, rat at this point. So when the distance is the largest, the rat can just run out of this circle. We can see from this example that there is actually a trade-off between this distance and this distance. When the distance of the inner circle gets too big, it may take longer time for the rat to finish one circle compared with the cat. However, if the circle is too small, for example like this, The mouse may not be fast enough to finish this distance compared with cat. It takes longer time for the mouse to reach to this point compared with the cat. So how can we find the balance? From the previous part, we know the constraints of the r, this distance, and we know the constraints of this distance. So for the radius r, the constraint is r is smaller than 1 over 4, and for the distance d, as we found from this original example, we know that when d is smaller than pi over 4, rats can successfully escape. So we know the constraints. D is smaller than pi over 4. And there is another constraint from the example. R plus D is equal to 1. From these two inequality, we know r plus d is smaller than 1 plus pi over 4, and this is greater than 1. So it's plausible to reach such combination. For example, we can just take r equal to something a little bit smaller than 1 over 4, like 0.9 over 4, and d is thus equal to 3.1 over 4. And as pi is equal to 3.1415 dal, d is definitely smaller than pi over 4. Then we find a solution for this question. So let's have a really quick recap. One solution for solving this problem is that we divide this part into two. So the first part is of distance r, and the second part is of distance d. So when the rat moves to this part, then the rat can do circular motion. And if r is smaller than 1 over 4, the time taken for rat to finish one lap is smaller than the time taken for the cat to finish one lap. So after running many laps, there will be a point where the distance between rat and the cat is maximized. And for the distance d, when d is smaller than pi over 4, we know that when cat is at this position, the rat can escape. So combining these two conditions, it's not difficult to find a solution, as there's another constraint, r plus d is equal to 1. So whenever we are making a choice, what we need to do is to make sure r is very closer to 1 over 4, but not greater than equal to 1 over 4, so that we can make sure d is smaller than pi over 4. So this is the end of today's Brain Teaser. Thank you for watching.